Welcome, everybody. And yeah, great to have you here for our next session, which is going to be about privacy on StarkNet L2 and will be held by Lauri. Lauri, take it away.
Thank you. So welcome to my session about StarkNet privacy. I have to in the beginning apologize that I'm a bit sick, so my voice might be a bit low, but I hope we'll make it. So what will we be talking about today? First, I'll give a small intro, who I am, what I do. Then we'll have a look at what is StarkNet, what can you do there, how does it work. Very quick look into zero knowledge, and then we'll go into a bit deeper layers into layer 3 privacy. So hello everyone, thanks everyone for coming. I'm Lauri. I've been blockchain developer for some 4 or 5 years now, and I found this StarkNet about a year ago and been developing stuff on top of it ever since. So if we're talking about privacy, why should anyone or why should you care about it? Why is it such a big deal? Well, to begin with, we can talk about censorship resistance. So if you have something you want to say, if you have something you want to share, or you have an opinion, it basically refers that nobody can censor what you can share or what you can say. So you have your freedom of speech and can say and do what you want. So, and this is tightly related to governments in a sense that some of the governments are maybe not so lenient. We are, of course, separated, like we are all remotely here, but the different countries have their own legislation and different ideas about what is allowed and what is not. So if we have proper privacy, we can get around some of the restrictions at least. And then, of course, we can consider it from a data point of view. Simply, if you have some personal data, some sensitive data like health stuff, or some identifiers like your name or date of birth or whatever you want to keep hidden, then you will need some sort of privacy. And if we talk about especially privacy in the blockchain context, if everyone knows what you own, if they go look at your address, they can basically see everything you own. And if you are kind of juicy enough target, they might start to target you in some phishing attacks and whatever they can come up with. So if you have some privacy there, they cannot basically know what an address has, and there's no point in targeting someone. And even if you start shuffling your assets across different addresses, if there's no privacy, people can just follow those assets across the addresses, and they can just follow whatever you do. Maybe you go trade your stuff here and there, and they can just follow the trail and see what you are doing. And what we used to call a minor extractable value is nowadays maximal extractable value. So what is one example of this? What if you're doing a swap in Uniswap or whatever decentralized exchange? If a bot notices that you're doing such a trade, and they calculate that they might profit somehow from it if they front run it, they can just insert their own transactions before your trade, and you will basically just pay a hidden tax on your transaction, and you probably won't even notice it. But it's just a bit more fees that you pay for your swap. So if we go one step deeper into layer 2, what it could offer, what it has, and why do we even go to layer 2? Basically, the blue box here in the middle says it all. Last year, the gas fees went skyrocketing because of DeFi and NFT and all that stuff. And it simply means that the network doesn't scale. So if we want any scalability, we have to think of some other alternatives. So there's the famous blockchain trilemma of decentralization, security, scalability. The Ethereum mainnet is very good for decentralization and security. So those are handled quite well. But then there's the third part, which is the scalability. And that's the tricky part, which doesn't really work. So that's why we are going basically one layer down into layer 2s. And if we think about StarkNet, the first time when I heard about it, I was like, okay, it has to be some Iron Man stuff. Sounds awesome. Let's go there. But then someone told me that it's not about Iron Man. It's something else. So it's a layer 2 network. It was started a few years ago. It went mainnet about a year ago. There's a company behind it called Starkware, imaginative name. And basically the whole idea of the network is that it aims to solve scalability problems of the mainnet. And the way it does it, it uses these things called Stark rollups, which is a proof system. And what is a proof system basically means that you can move all the heavy computations off chain, and then you bring the proofs of those computations on chain and only verify those. And the proofs of those are quite small, and verifying them is quite fast and doesn't cost much gas. So you save a lot of gas when you don't have to do the computations on chain. And if we have a look at the bottom part, here's the typical Ethereum transaction or a block. There's a few transactions, a miner forms a block of them and then broadcasts the transaction, and all the rest of the nodes start verifying that, yeah, this looks fine. This is a great block, let's accept it. And when we go to the StarkNet side, it gets a bit different. There's a lot more transactions you can fit in a single block. And once you broadcast a transaction, it goes to a sequencer, which basically gathers them into a block, and they are sent to a off-chain prover, which generates the proofs based on the transactions, and only that proof is sent to the mainnet. So it doesn't matter too much how many transactions there are, the proofs will be small anyway. And the network somehow seems to love Python. A lot of the tooling is done in Python. And the native language of StarkNet, called Cairo, all of its toolchain, well, not all, but much of its toolchain is in Python. And even inside the language itself, there are these special instructions for the prover called hints. And those are all written in Python. So if you want to write Cairo, you basically have to write some Python also. If we had a quick look about zero knowledge, it's the concept of you want to convince someone that you have some data without telling what the data is, which sounds very odd, but once you start to understand how it works, it's actually quite beautiful. So for example, we are going to a bar, we want to prove that yes, we are of legal drinking age, but we are a bit sensitive and we are private. We don't want to tell them how old we are. And in reality, the only thing the bar needs, they need to know if you are of legal drinking age. So this is the kind of stuff we could do with zero knowledge. You can generate a proof that you are of legal drinking age, and the bar owner reads the proof and knows that yes, you are. And that's the only information they would get. And in blockchain context, it's usually used for hiding transaction information. And it's basically mathematical magic. It's fun, but complicated. So isn't StarkNet already zero knowledge? Well, it's not. It's often called ZK rollups for some reason, but most of those rollups are not zero knowledge at all. They just use the same technology. So that's why Starkware, they use the term validity rollups instead of ZK rollups, which is more accurate because it only guarantees the validity of the inputs, but it leaks some data, at least in theory, so it's not zero knowledge. And then if we go one step even deeper, now we were in StarkNet level layer 2. If we go to layer 3, we can see that the relationship between layer 3 and layer 2 is about the same as layer 2 and layer 1. So transactions are posted to the underlying layer, and we get security back. So we send the proofs of the transactions from L1 to L1, no, sorry, from L2 to L1. And because of that, we gain security. So if anything goes wrong in our net layer, we can always go to the underlying layer and get our assets back there. So even if the whole network gets destroyed tomorrow, everyone can go to layer 1 and get their assets back from there. That's the security we get from the underlying layers. And it's the same for layer 2 and layer 3. We gain security and we post transactions. And what can we do in the layer 3 and what kind of privacy there is possible then? Well, the only requirement for creating layer 2 is basically you have to share some state updates to the underlying layer. Otherwise, you don't get any security from it because it doesn't know what the state is in your layer. So you just have to post state updates in some fashion to the underlying layer. But otherwise, it's your own network and you can have your own rules. So it doesn't even, if it's just layer 3 on top of StarkNet, it doesn't have to be anything like StarkNet. It can be centralized, decentralized. You can decide. Maybe you can even adjust the privacy that on Saturdays you display all data and on Tuesdays you hide everything. It's all up to you. You can really decide. And if it happens to be a proof system, then you have to start considering things like, okay, someone has to generate the proofs. Who is it going to be? And this requires the input data, or basically the transactions. So the one who generates the proofs, they have to know something about the input they get. But beyond that, it might be fully private. Nobody else basically needs all of the information. And maybe you want to aggregate the data. So for example, if Alice sends 1 ETH to Bob and Bob sends half an ETH back, do you store information about both transactions? Or maybe you just store information about Alice sending half an ETH to Bob. Is it enough for your case? It depends. You can decide. And then there's these two concepts about state and state transitions. Are they public or private? When they go to the layer 2, they basically become public. So that's a kind of like drawback in this system. It cannot be fully private. It can be fully private inside the same layer. But once you go 1 layer deeper, you have to publish the state updates, unless the underlying layer is somehow private also. But in this case, you have to publish the state update in public format to the underlying layer 2. So we have the possibility of about the proofs and the state. You can decide which parts are public, which parts are private. But if you happen to manage to combine both of those and make them both private, you will have basically full privacy inside the layer. So some key takeaways. StarkNet is not it's not a privacy solution, but it simply enables and allows us to build various privacy solutions on top of it. And the zero knowledge, it's very strange stuff. The more you think about it, the more weird it gets, but it's very cool once you start to understand it somehow. And then in the layer 3, we have lots of options, lots of privacy options that you can choose from if you decide to go all the way there. So that's my presentation. If you have any questions, I'm very open and to answering anything.
Yeah, so if anybody has questions, please do put them in the Discord and I will read them out. And there was already one question by Miko who was asked about the state. So is the full state available or somewhere for querying, or is it never archived?
If we are talking about layer 1, the full state is not available there because we only have the proofs. And if we want to get something from those proofs, we have to generate lots of states to get our assets. If in that sense we are talking about the states. But I'm not entirely sure in what format the layer 1 proofs are sent.
Okay. Yeah, if anybody else has questions, please do drop them. We still have a couple of minutes. And yeah, thank you so much for joining, even though you're sick. And I think now at the moment in the chat, there's a discussion about if Solidity is the future or not. So maybe if you want to add any thoughts on that, you can, since you have a lot of experience as well working with.
Yeah, I used to have a slide here which was comparing Solidity and Cairo, but I took it out because of time reasons. So there's a transpiler from Solidity to Cairo. So in theory, you can use exactly the same contracts in StarkNet, but in reality, I feel like it doesn't make sense because the constraints are totally different. Cairo is the StarkNet is basically computation is for free almost, except and in mainnet, computation is very expensive. So in the mainnet, you're optimizing different stuff that you should also optimize in StarkNet. So it doesn't make sense to use the same contract and the same architecture anymore in StarkNet. So in that sense, it doesn't make a difference, because if you still have to rewrite it, why not write it in a different language?
Yeah, that seems sensible. So just gonna encourage everybody to put any questions you might have about StarkNet or maybe zero knowledge proofs in the chat. Also maybe to you. So how do you explain what you do to like normal people like myself?
I guess it depends on what kind of experience you have. If you understand something about Web3 or crypto, then it's somehow, I can say that I work on layer 2s, for example. Oh, okay. If I try to explain to my mom, I don't know. I work on Bitcoin. I don't know.
Yeah, no, I think that's a challenge though for a lot of people in the space, like just explaining it. And I think that's also how we know we are not there yet.
Yeah,
probably.
But that's how it goes. We'll get there eventually.
Yeah. Do you think StarkNet is going to be a huge contributor to that, enabling more scalability?
For scalability, yes, I believe it. It has, of course, it's difficult to go there because you have to learn new language and so on. Yeah. But if it kind of makes it, then it's gonna be one of the biggest players. I think it's early.
Early days. And why did you decide to go to StarkNet? Because there's also others, like I think Starkware, and I think Polygon now also has a ZK EVM. And
yeah, a year ago there was basically ZK Sync and Starkware stuff, but neither of those were in production. And basically a friend of mine was asking me, hey, why don't you want to have a look at this? And I was, why not? So coincidence, no real reason.
Okay, yeah. Okay. Okay, I'm not sure, but there's also a question about Cairo 1.0, but I'm not sure it's actually related to this one.
I can still answer it.
Oh yeah, sure.
There's going to be a full blockchain reset in a few months, and at the same time they update the language version to 1.0, which means that all the contracts will have to be rewritten, which is not too fun. But so yeah, it will screw up all projects unless they happen to be upgradable. But then when we get to Cairo 1.1, everything should be easier to code.
Hopefully. Okay. Well, I think we will just stay here in case anybody else has any questions. So how do you feel about the market? I mean, does it impact you in any way? Because you're working on something like very abstracted away from all the centralized stuff.
Well, this is a great market to be building. So
yeah, it's true.
As long as you have the money, then this is a great time to be alive.
I think a lot of people lost the money.
yeah, that's an issue. But it's just kind of, yeah. If you happen to have the money still.
Yeah, I agree. It's good because there's less distraction and less speculation.
Yeah, and all the speculative projects will just die away.
Yeah, it's like a detox.
It's healthy.
Okay. Yeah, I think we will be kicked off by the system in a minute anyway. So yeah, if anybody has questions for Lauri or wants to discuss things with him, I'm going to put the face-to-face link in the Discord channel so you can catch him there and ask anything you've ever wanted to know about zero knowledge proof. I mean, I must agree, the more I read about them, the less I understand them. So that's really, so I have now zero knowledge as well.
I know the feeling.
So yeah, yeah, face-to-face it is. And yeah, thank you so much, Lauri, for joining, even though you were a bit under the weather, and definitely interesting topics. And yeah, everybody who still wants to ask things, please do join the face-to-face, which I'm just putting in the Discord now.
Yeah, thanks for the possibility. Thanks for everyone for coming.